Welcome back to another video. For those who've been following me for a long time, thanks for that. You would know that I don't have a BMS on these batteries here, and I do a lot of manually monitoring the batteries. So for 5 years now, we've had any issues, and I've always wanted to put the BMS. The trouble is, it's the costing. I know you will say, well, okay, the cost would be much cheaper than burning down my house or my shed, and that I agree fully. That's why I do a lot of manually balancing. And what I've been doing is having these little resistors. Hard to see. This one's a 20 watt 8 ohm. In parallel, the 4 ohm. So essentially, I put it over each pack. And then the excessive voltage or power will burn off in heat to try and maintain it a bit better. So what I've found is a little device that will do that automatically for me. But first I want to stress, it is not a BMS by any means, and it should not go unchecked. All it's going to do is automatically turn on that resistor when it reaches the designated voltage, 4.1, to burn off the energy. So let me show you what I found on eBay, and I'll show you how I plan on making it work, because there's a few variables in there that you can change: high voltage, low voltage, when it's on, when it's off. I'll go through that now with you, but first I'll show you what I've got, and then we can have a play with it. So this little device here is what they call a voltage detection module relay switch, charge discharge monitoring protection. And the idea is, it's got a little voltmeter on there hooked up to the battery, so the battery terminals, power supply is a 12 volt unit, and the idea is set the values. At the moment it's saying the battery is 4.1 volts, thereabouts, very close, toggling between 4 and 4.1. The idea is, if the batteries are charging and I don't want it to hit 4.2, ideal world, you know, once again, you don't need BMSs, but this is not an ideal world. So what it's supposed to do is, when the voltage gets 4.1 and higher, it will turn on the output. Basically that's a switch, which therefore turns on through one of these resistors and burns off the excess energy. So there's a few value parameters for that. You can actually set it to be opposite. When it gets to a certain voltage and above, it will turn off, and so on and so forth. But I'm interested in turning it on. So we'll set this up. It's a little tricky to read because it seems to be glowing as well. Oh, there we go. I'll turn off the light so you can see it. So you press the set button. That's parameter for which would it do. I turn on, off, whatever. So for what I want is 5, and select that. Okay, so this is the one I want to set it for. Fixed point monitoring. So it says when the measured voltage is higher than V1. V1 is the top end voltage that I set for 4.1 volt. The relay is turned on. The lower V1, the relay is turned off. Okay, so what that means is the top end voltage set at 4.1. When the supply charges the battery more and hits more than 4.1, let's turn on the relay. And when it drops below, turn off. So let's go through that. Press set. Get to this mode. F01, bring that up to 5. Press the set. And it's on. So now that's set for the top end. Let's make sure our values for top end and bottom end voltage are set. Press set. Set again. 4.1. 3. That's 8 points. So let's bring that back down to 3. 3.0 and set. And set. Now it's on. So now what that will do is, when this battery charges up to 4.1, it will turn on the relay, which will turn on the switch, and it will burn off the resistor, burn off the excess power through the resistor to bring that voltage down. Let's do 4.2 volt. It's taking too long. Charge. So when it goes up to 4.2, there we go. Just turned on the switch. The little light showing. So it keeps flashing. It keeps turning on and off, on and off, on and off. Green light means on or closed circuit. And why it's doing this, because every time it turns the switch on, goes through the resistor puts that load on the battery, the battery voltage sags below 4.1, and then it turns off the switch, makes the voltage rise back on the battery, and then the whole process starts all over again. So my theory is, if this was set up on one of those packs, it's going to have virtually no voltage sag, which will stop that from happening. So at the moment it's charging at 1 amp, 1.3 amps. It's trying to hit the 4.2. So my thoughts were, if I leave this, eventually that will steady off to be on, because this will charge up more than this is dissipating the heat back out of the battery to pull that voltage down. So eventually it will start to stabilize. Of course, keep doing this. The change could probably wear out that relay, or maybe stress that electronic, burn some chips, I don't know. Well, I'm convinced it's going to work. So I'm going to go and plug on one of these battery packs and simulate it and see what happens. Let's simulate this on the batteries. The battery there says 3.8, which the meter says 3.8. So at the moment it's on. So what I've done is I've set it to be 3.8. So if the measured voltage, which is, we're measuring the voltage of the packs, if that's higher than V1, as in where we set the high top end voltage on here, then it'll turn on the switch. So therefore you have to be 0.1 volts lower than where you're trying to aim for. So at the moment the circuit's closed, running through the resistor, pulling the pack down, but I have got an additional load on, 1000 watt heater, solar's turned off, so I'm taking 1000 watts nearly out of the batteries. So soon, when that gets to 3.8, that should turn off. When that turns off, these resistors will go cold. So at the moment they're warm, it's gone through that circuit. Let's just have a watch. So it's not as bad as one cell, but can you imagine 14 of these clicking? That'd be quite noisy in here. So all I've done is I've just got it off a power supply, 12 volt power supply. And you can see toggling when it hits 7. So 3.7, it's off, because see, 3.79 is still 3.7, which shows on the meter 3.73. Obviously not exactly a match. I'll turn off the heater, the whole voltage should jump up on the yep, so it's jumped up a little bit and went back into discharge, because I'm going to say that works well, but won't really know until I get another 13 of them and connect them on these battery packs. So I'm going to figure out which is the best layout. So essentially I've got to run power to all of them and connect these straight to the battery pack. Now that it's installed, looks reasonable, relatively clean. That says 4.1 is actually on. The resistor is quite warm. Just a bit of glue each side, and a supplier wire. So this here is where my cable management really lets me down. So essentially this is parallel to this one, which is one big battery. So in theory I should only need the one for these two, but we know that doesn't happen like that, because for it to filter through these little balance wires on high charging current or discharging, it'll take a while to filter, and then they can drift in the meantime. So with the power supply, my plan is to do what they call, I guess, the daisy chain on the Batrium, is just link the wire over, and that'll be probably the neatest way to continue the power supply right through. Otherwise everything else is very neat there. I've got all the little unit measurement thingies on there now, with the third pack on the desk for putting the wires together. So where I'm at to now, no doubt the first one works properly, flawlessly. It's been trialed for a while now. So I've got the second one in. Now obviously if the power supply has got the power in it to do it, the theory should be I should be able to just parallel the positive negative to the positive negative. But if you have a closer look, you can actually see that the negative is not in, but yet it's still working. It is bright on the camera, but it is 3.0 volts each, so they're slightly different in the pack values. So when I tried to connect negative to negative, it became a short. Somehow the negative here is a dead short to the negative anywhere along the line. So that tells me I can't just tie negatives together. So I have to make individual power supplies. Hopefully that will work. Hopefully the negatives are going to be isolated to each other. And that way it will also give consistent voltage, because from here you get your 12 volt in, but when it gets to here it's a 8 point something volt, and then when it measured to the next one it was less again, that it actually wouldn't turn on the LEDs. So I've got a little plan that I'm going to work on and see if I can get it to work, but it might mean I have to make 14 individual power units. As you can see, this 7 is done, and I've got the power supply here, so that is what gets the voltage supply from each pack. And then I got that's a potentiometer, and that little gold thing there is what you use to adjust the output voltage, which is on there. But once again, negative is not connected because it doesn't need to be. So this setup works well, because if for whatever reason the power supply gets turned off, which is supplied from here, I'm going to lose all the settings. Then I won't do any balancing. Well, I hope that this video was a little bit insightful to a makeshift BMS, but I really truly stress this is not a BMS by any means. All it is to help you manually manage the top end charge, and I guess if you want to play with the bottom end charge of the batteries, that's what this is designed. Now if you just heard it, you can see the light reflecting off the resistor here. It is working.